Hi guys, today we're going to be going over USACO 2019 sleepy cow sorting. So in this video, Farmer John is trying to sort his N cows conveniently numbered 1 through N before they head out for breakfast. And the cows are standing in a line in the order of P1 through PN, and Farmer John is standing in front of cow P1. So he wants to reorder them so that they're in the order of 1, 2, 3, all the way up to N, with one cow next to Farmer John. And the cows are a little sleepy, so only the cow who is currently in front of Farmer John is paying attention to him. So he can only instruct the cow that is right in front of him to move K spaces down the line. And K is in the range of 1 through N minus 1. And remember this range because it's going to be pretty important later on. So the K cows whom she passes will amble forward, making room for her to insert herself in the line after them. So for example, let's say that we have N equals 4, so there's 4 cows, and the cows start off in this following order: 4, 3, 2, and 1. The only cow paying attention to Farmer John is cow 4, so if he instructs her to move two paces down the line, then the order will look like this. And notice how basically the cow just inserts herself into here, and all the cows in the forward are just going to move one space up. And so now the only cow paying attention to Farmer John is cow 3. And so now Farmer John would give cow 3 a instruction and would do this until all 4 cows are sorted. So basically, the input that we're given is going to show first n, which is the number of cows, and then the second line contains n space separated integers p1, p2, p3, all the way to pn, indicating the starting order of the cows. As for the output, we just need to output a single integer, and that's going to be the number of steps before the n cows are in sorted order. And that's if Farmer John acts optimally. So in this example, we have 4, 1, 2, 4, 3, and the sample output is 3. Now, at first glance, you might not understand why it's 3, so let's go ahead and draw it out. Okay, so this is our sample input, and we have 1, 2, 4, 3, right? So I'm just going to go ahead and sort it for now. The first step is just going to be to make it 2, 4, 1, 3. And then it would be 4, 1, 2, 3, and then it's going to be 1, 2, 3, 4. That's sorted, right? So Farmer John is at the very front of the array, right? And so you can only talk to the first number. And because of this, our array would be sorted if we could talk to the last cow, right? But we can't. So because it looks like there's not really much we can do here, we kind of have to like quote unquote restart. And so we have to move this 1 to the very back. And you would think that that's kind of resetting our progress. But like I said, there's nothing we can do here that will change it without compromising this 1, right? And if we put it like right here, it would just make it would just make the process much longer, right? So we kind of restart and we put the 1 behind the 4. And after we do this, what we can do is, now that we have some numbers in the back that are chronologically ordered or sorted, we can basically just put the numbers in place and they'll fall in place. So notice how we only have one number in the back sorted right now, and then we have 2 numbers in the back, and then 3 numbers, and then soon we have all 4, right? So with each move, we're just trying to put more sorted numbers in the back. And that's the move that we do here. If we put the number here in the back, we still only have one number sorted. But if we put it here, now we have 2 numbers sorted. So you can think of it like that. So the as you can see, like the focal point is kind of just how many numbers in the back we have sorted. So that will help us determine our answer. So for example, like in this example, we start off with 2 numbers in the back sorted. So we're going to switch this to 2, 1, 3, 4. Now we have 3 numbers in the back sorted. And then finally, we have 1, 2, 3, 4, which is all four numbers, right? So now you can see that there's a correlation between the number of numbers that are sorted in the back and the basically the solution or the answer. So if we have more sorted numbers in the back, then our answer will be less because it'll take less steps to sort all the cows. So another example is 3, 1, 2, 4. Now in this example, three numbers in the back are sorted. So all we need to do is move our 3 right here. And if we do that, we'll get 1, 2, 3, 4, making all numbers sorted. So our method in our program, all we have to do is check how many numbers in the back are sorted. If it's 1, then our answer is going to be 3 immediately. If it's 2, then our answer is immediately going to be 2. If it's 1, or sorry, if it's 3, then our answer is immediately going to be 1, right? Because if we know the number of numbers that are sorted in the back, then we immediately know how many steps it's going to take. So now we can just go ahead and program that. Okay, so as you guys can see, I have some stuff already written down. I have my buffered reader in and my print reader out, which will help us take in input from file and output to file. And I have my N, which is going to store the amount of cows, and my P, which is going to store the initial positions of the cows. And then I set that all up in the main method. So first I'm going to take in N using the buffered reader. Then I'm going to set up P, which is going to have N amount of cows. And then I need to use a string tokenizer in order to take in the N amount of N cows starting positions. And then I'm going to use a for loop to do that. So for P of I, that's going to be equal to the integer value of the next token of ST. And when we solve, basically the thing you need to remember is the amount of sorted numbers in the back corresponds to the amount of steps we have to take. So if we have one sorted number in the back, that means we have to take 3 steps to sort the array. If we have 2 sorted numbers in the back, we have to take 2 steps. If we have 3 sorted numbers, we only have to take 1 step. So and if we have all the numbers sorted, then we don't really need to do anything. We have to just output 1, or sorry, 0. So that's why we're going to have a Boolean called sorted, which is going to be equal to false for now. And we're going to use that later to do our corner case, which is going to be when all of the numbers in the array are sorted, and we have to output 0. But for now, we're looking at the normal cases, right, where the array isn't sorted. So what we're going to do is we're going to start at the very back, right? Because we check the numbers in the back and see how many are sorted. So int I equals n minus 1, right? And I is going to go all the way to 0, but not to 0. It's going to check 1, and you'll see why later. And basically inside of this for loop, we're just going to check if P of I minus 1 is greater than P of I. And if so, right, then we're going to print out I, and I'll explain why. So the first thing is I said that we go to 1 but not to 0. This is because we're checking for I minus 1. If we went to 0, we would check for I minus 1, which is negative 1, right, at 0. And there is no P of negative 1. That doesn't exist. So we would get a null pointer exception. And the reason why we print out I is because that's actually the amount of steps that we have to take. For example, let's say we had the array 3, 1, 2, 4. Now, if we have 3, 1, 2, 4, then let's just simulate this whole for loop, right? We check these two, and they are sorted. So we go from 3 to 2. We check these two, they're sorted. So we go from 2 to 1. We check these two, and they're not sorted. So right now, because they're not sorted, this is going to be true. And that means we print out 1. And it's true, we have to take 1 step to sort this thing. And that now it's sorted. So yeah, I is just the number of steps we have to take. It's a neat little trick, right? And to reduce the time we take, we just break here. And also we need to set sorted to false or sorted to true, right? And basically, if sorted if sorted is false here, so let's say if sorted equals false, then we'll just out.print ln 0. Actually, now that I think about it, it would make sense to put this at true and put this as false and this as true. So we can just remove this. And basically, so sorted equals true, right? If sorted is true, then we don't have to take any steps and we print out 0, which is why I said that it makes more sense to put it as true here. And if it's false, then we know it wasn't sorted at the beginning. So that's why I said that as well. Um, and yeah, so this is our corner case. If the array started off as sorted, we don't have to take any steps to sort it. So print out 0. And now we are ready to submit. So yeah, as you guys can see, we pass all the test cases. So that was sleepy cow sorting. If you guys have any questions on the diagram or the program, just let me know in the comments. And as always, thanks for watching.